Next we see question number 5, coplanar force system. So they said in a coplanar force, the coordinate system, A to A comma H the coordinate, moment is capital H, moments about that point, and this point is a 2H. If the resolving component parallel to the y equal x, how that line, you know, y equal mx, gradient is 1, y equal x passes through the origin, therefore 45 degrees here because m is 1, right? So this is system, the forces resolve parallel to this line, that component they say 0. So every coplanar system can be reduced to like this pattern. A single resultant force at the origin, or total x component, total y component, resultant components, and it can resolve to a moment or a couple at the center. Let's say it's a G, moment at the G. Resultant moment is G here. Every system can be resolved into another system, new resultant system, like this at the origin x and y, or single force capital R resultant and a couple G. That means the total algebraic summation of the couple is here G actually, and total horizontal force is x, total component vertical is y. Okay, now they ask find the x, usual notation, what is x value, total horizontal component, y is total vertical component, G is the resultant couple, right? So therefore we use it, what they say, special case here, it will resolve along the line, the answer is 0. Now first we resolve the forces along that line. So you can write resolve the forces parallel to this line, or y equal x line along that. So total x component, resultant component, horizontal x. If you resolve, what happened? X cos 45. Yeah, x cos 45. Capital X cos 45. Next what? Same here, y. Y cos 45, y sine no matter. Sine and cos 45 degrees, same answer. This equal to 0, right? So divide by 45, cos 45, sine 45, both same solution. So I hope you completed successfully. Once you complete only, it's very interesting answers. Solutions are very clear, otherwise useless, only data waste only if you copy my answer. So you have to work, let's say before 1 week or couple of days before I publish my question papers. This is the first equation, x plus y equal to 0, x equal to minus y, right? Okay, next we take about the moment. They say take about the moment is capital H, about B is 2H. Then first we take, right, moments about A. Moments take about A, that direction, if I take that direction, so what the algebraic moment equal to resultant moment, that idea. So about A, right? So H, amount, that is H equal to the same direction, you can write all that, H equal to G, okay, G, and how this point become the other one, moment about A, take this y, x, you can't take this x is along the A, x is along the point A, the y is available, so y other side, is it y other side, okay, so minus y into, the distance is 2-way, right, distance is 2-way, y into 2-way, then I say second equation, or you can take G equal to that, G is the resultant moment, or that's called couple, resultant moment equal to algebraic summation of the other moment, right? The direction is important. Similar, next take moment about B, take the moment about B, that is 2H, okay, 2H equal to G, you know, moment for this G, no distance, couple independent of the distance, right? G and X about distance h, x into a, force into distance is the moment. So capital X into about a, distance is a, right? So the same direction is it, plus x into a. Then I say my third equation. That's only a 3 unknowns, 3 equation. Solve and find this x value, g value and the y value. So what they asked to simplify. So think a simple method. If you remove the g, that if you subtract, what happened? 3 minus 2. 3 minus 2. 2h minus h, that is h. G cancelled. X a plus capital Y or 2y into a. Okay. From the first equation, you know x equal to minus y. In the first equation, x equal to minus y. So we apply there. Therefore, h equal xa, can say here minus 2xa. So h answer is, or the x answer, but the x answer minus h over a. Okay, x equal minus h over a. If you work check, direction is other side. Okay, usually we use this anti-clockwise direction, the moments in this coplanar system, right? Okay, then what is y answer? Therefore, y becomes positive h over a, is it? Y is positive h over a. Y is positive h over a. Now go to the second or the third equation, find the g. Put x for this minus h, so 3h is it? G equal 3h. So what is g? Resultant moment. So here h, here 1h, here 2h means 3h. G is the resultant moment, right? The first part is over. Find the x value, y value and the h, the g value, okay? Now they ask, show that the resultant force act along the line of magnitude. First you can write the magnitude. If you know x, if you know y, but the resultant magnitude is square root of the x square plus y square. But in the vector component, how to write the resultant? Resultant answer. Resultant is r. Therefore, r equal what? X into I plus y into j. Is the way I will write the resultant answer, x into I plus y into j. So what is that? So you know the x answer minus h over a into I plus y is positive h over a into j. So they provide the answer, take the h over a out, h over a out, then what is the answer? Minus vector I plus vector j, right? This is the resultant answer. And now they ask the force act along that direction, that line, the line of action of the resultant's equation. So how to work that one? How to work that part? What the idea? How to work this resultant magnitude is okay, is the magnitude resultant, okay, the vector form, ij component form. Now we find the line of action of the resultant. So I draw the resultant diagram reduced to a single thing here. If I mark something like that, it's the resultant line, right? That's the resultant line. So if they ask an equation of the resultant, we should take a Cartesian pattern, Cartesian component x, y and build up an equation, right? So if I take a point here P and mark x comma y, so to build up an equation in terms of x comma y, and that's the answer. So what do you mean x comma y, point P, any point you can take along this line. So from origin here, x distance, y distance, right? Then take moments about the point P, write this sentence. take the moments about the point P. So write the moment theorem, algebraic summation of all the forces equal to resultant moment. Resultant passes through this line, there was a 0, right? So what is that? If I write this point P, take point P, the moment is direction x into capital X into distance is y, and y the other side minus y into minus capital Y into distance is x, plus g, okay, plus g. G hasn't any that distance, g plus g equal to 0. This gives you the answer of the equation of the line of action. So simplify x4 minus h over a into y, y4 h over a into x, g4 3h. Therefore rearrange the answer. Come, this answer is given there, x plus y less. Therefore x plus y, all h cancel, multiply a, x plus y equal to 3a. Well balanced question, simple problem for a structure type question, right? Okay, see next question, problem number 6. It's a static question. I hope you completed successfully. So waiting for my answer, diagram, solutions. It's an important question. Diagram is sometimes complicated. Draw a proper diagram to get that problem 6 answer. So they said AB and BC are two uniform rods of weight W which are smoothly hinged at B. When the system is suspended from A, angle ABC makes 90 degrees. System is in equilibrium by joining the extremes A and C by an inextensible string. So when drawing the static diagram, force diagram, forces should be balanced. For equilibrium, there are 3 forces, all 3 passes to a single point. Or any this framework idea, system should be an equilibrium type, you should draw the diagram. If system not in equilibrium, the forces be wrong therefore. So here how this diagram, if I mark the point A here, from here they suspended that something like this, or they, or here any point here there. So then this one rod, okay, and this the other rod. Is it like this? Okay, they say here 90 degrees, okay, here 90 degrees. This is the point C. Because here W, see if I show this vertical point, vertical through A, they said somewhere that angle, vertical, if AB makes an angle theta with the vertical line, therefore this is theta. They said the AB and BC are 2 equal rods. That means weights equal, the length of the rod also equal. If I say 2-way, if I show force diagram W, I take as A, right? Here 2-way. 2-way is the distance or length of the rod. There 1A, 1A. So see, if I take the moments about this W this side, therefore other W should be this side. It's actual diagram. If you mark the W here, both turn through completely, that therefore that equilibrium collapse. You can't take a proper static diagram. Therefore the second occasion W you mark somewhere here. Length is A, you also completely A length, right? Actually this is an isosceles right angle triangle, but diagram is important. And now they say they tied this A and C by a light extensible string, okay? Therefore tension available T, also T. They suspend or attach to somewhere from here, no matter about that point. The question is show that tan theta equal to 1/3, tan theta equal to 1/3, 1 part, Also the tension in the string given. So what the idea here, force diagrams. Here also we can mark, I can mark some forces available here, horizontally, vertically component. But in the problem they won't ask that, therefore I not mark, otherwise I can show that also. If it's upward, if I mark x1, so y1 here, and downwards then here y1, the same forces comes here. If I mark here x1, here x2, so actually that is not necessary. The problem is find the t value and the angle. So you know this is 45 degrees, okay, because of isosceles triangle is completely 45 degrees. Here also 45 degrees. The diagram is the main part here. If you draw the proper diagram, then you are correct. Otherwise difficult. Take long time to complete a successful diagram, proper diagram. Okay, 45, 45. See any other thing if I mark the, if I draw, this is horizontal. This was not necessary, this forces, right? If I draw horizontal part, theta 90, 90 theta. Here theta is a check value. Here theta, therefore alternate angle, okay, right. So what the idea to build up a theta, to find the theta value, think any method. Therefore we won't remove the all forces, vanish, to eliminate without a force we take an equation. Therefore take the system, for complete system. For system, if you take moments about A, what happened moments about system means what? Here T cancel. This joint reactions also cancel. Only weights available, right? So this side W, and some distance comes, angle comes, you can find the first part answer, right? You have to write first, write this. For this system, for the system, take moments about A. For system, takes moments about A. Takes moments about A. So we mark the A here, takes moment about A. So what is moment? Force into distance. You can write this W. Take this W, what is moment? Force into W into, what the distance? Line of action here, what is that? Here A cos theta, therefore A sin theta, okay, that's A sin theta, W A sin theta, and minus this side, okay, minus W, what the distance of this line of action? Here line of action, this part. Think an easy method. If you know this complete, this horizontal, subtract this, okay. If you know complete this part, subtract this distance. But this part, A cos theta, completely this part, what is AC length cos 45 plus theta, is it? AC cos 45 plus theta, the complete length, this complete part, and subtract this portion, right? So, okay, what is AC? Pythagoras law any form. Here 2a, here 2a. What is AC answer? What is AC answer? Square root of, here 2a, here 2a. That is 4a square. Is it okay? Plus 4a square. Therefore 8a square. 8a square inside the root is the AC value. Or you can write this 4 times 2. Take the 4 out. So before work, better you calculate this part separately. 2 root 2a, right? Okay, therefore this W is okay. Minus W is complete distance is what? AC cos this, okay? 2 root 2a cos 45 plus theta minus this portion is A cos theta, right? Minus A cos theta equals 0. So simplify, I hope you can go to the first part answer here. A simple well-balanced question for a structure type 25 marks. So you can cut by A, cancel, cut by A. here A cancel. Also you can cut by W, so here sine theta, carry that side, what, 2 root 2 cos 45 plus theta minus cos theta. Okay, now think an easy method by using a trigonometric parts. So anymore, can I take the cos theta this side, or sin theta plus cos theta equal 2 root 2 cos A plus B, cos A cos B, cos 45 cos theta minus sin 45 sin theta. Okay, so what is that? Sin theta plus cos theta. You know, cos 45 1 over root 2, sin 45 1 over root 2, take the 1 over root 2 out, so root 2 cancel, therefore 2 into cos theta minus sin theta. Okay, we have rearranged it total. If you take one side there, we have at 2 3 sin theta equal to 2 cos theta. Therefore tan theta is it okay? We have 1/3 sin divided by cos is tan, right? Tan theta is 1/3. Next, the question is find the tension. The answer also provided there. Find the tension is T. So think a easy method. Still they not asked about the result. This resultant act at the B, the total reactions X, Y, nothing. Therefore, to avoid that, you take a moment. For rod BC, write this. For rod BC takes moment about B. For rod BC takes moment about B. For rod BC takes moment about B. Okay, so write that B. So take a direction that side. That side we mark, right? T, force is T, force is T. What the distance? What the perpendicular distance like this? You know here 45. Opposite known, hype is two-way. Opposite known, unknown, hype is two-way. So what is that? Sin 45. If you apply sin 45, opposite hypotenuse, two-way sin 45, two-way sin 45, that is 1 over root 2. Yeah, check that, 2a over root 2, right? The direction, the tension force, right? Next one, and it's okay, it's W, minus W, check that, minus W this side, minus W on the line of action, this part. What is that? A cos theta, this is A, right? If I took the length of the rod is 2A, here 1A, A cos theta, okay, A cos theta. So W, A cos theta, 0. Therefore you know cos theta, what is tan theta? Find the cos theta. Tan theta 1, here 3, therefore this is square root 10. Okay. So what is that? 2t over root 2a cancel. Here what? W cos theta 3 over root 10. So the T answer is, you can see the T answer, you cut by root 5 here. So the answer there, check, will do 3 root 5. 3 root 5. How to simplify out this problem? 3w, okay, 3w into root 2 over 2 times root 10. So now you simplify this. If I multiple up and down by this root 10, cut by root 2, here 5. Here 5, up and down, multiple by the root 5, here 5, and here 2, okay, here 5 times 2, 10, right? So So 3W or 3 root 5W over 10. That's the answer. Multiple, you rationalize the denominator, get it simple, that is pure maths part. Okay, see next question. Work, power, energy problem. So I make many questions, previous all models applied. I shown problems under work, power, energy. It is also one of the exam problems, especially the structure type. So I hope you complete this all. Next question number 7. Problem number 7. How that the power of a vehicle of mass is capital M kilogram. Therefore, it's no problem. Otherwise, you turn into the ton given to kilogram. And H watts, the capital W is watts, not kilowatt. Therefore, very easy question. The resistance R Newton to the motion of the vehicle is a constant at all conditions. So everywhere it's capital R, right? Maximum velocity of the vehicle is V meters per second when it's moving up on the inclined plane. So maximum speed mean on that condition acceleration is 0. Okay. The inclined ratio is divided with 1:n. But the meaning of this 1:n, the ratio, the inclined angle is theta. If the inclined angle is theta, the sine theta is 1/n. Sine theta is 1/n. That's the meaning, right? And maximum speed of the vehicle when coming down the same inclined plane, there is 2V meters per that. So first we complete the R value. So I hope you complete this. So diagram is important. If I show clearly the diagram. At the moment I need the two diagrams. Here theta, you know the sine theta is 1/n, right? Sine theta is 1/n. So we work first occasion. Particle moving, I say tractive force is P1. Its maximum velocity V, all meters per second, therefore no problem here. And capital M mass, then we call capital Mg the weight, and we see the R is the resultant. This is figure 1, first occasion figure 1, and I show the next also the second occasion. This vehicle comes down. In that case, maximum velocity 2v, maximum velocity means like a constant velocity, therefore acceleration is 0. So here's the mg, capital MG its weight. So I see the force here P2, and the resistance always a constant part, right? It's the second occasion. So I hope using these two you can complete the first part answer. Complete the first part, the R equal 3 mg over n. So there are two equation familiar, we use it here. One is Newton's application, F equal ma. Other one equal to what? The H equal PV, that means power is equal to tractive force into velocity. So we apply that. So apply F equal ma for this diagram in moving up. So total I apply for vertically upwards P1 minus mg theta 90 theta mg sine theta, okay, minus r equal mass is capital M, but the acceleration is 0, right? P1 minus mg sine theta minus r. Otherwise you can take that P1 minus r equal capital M. You know sine theta, last you can apply that. This is my first equation, right? So my first equation. Next apply H equal PV formula. Okay, the power equal to 20 force into velocity. So power, they say in this case also capital H is the power. Watts. I say first occasion P1, velocity V, second equation. Okay. Next we come here. The same thing apply for this formula. Right here for second, okay, it's for first. So everything for the figure 1, right? And apply for the second figure. Second figure apply same method as coming down. So apply down. That's P2 plus mg sine theta minus r equal to 0. Okay. Otherwise I can say P2 minus r equal minus capital mg sine theta. You know the theta value, right? Third equation. Next apply H equal PV answer. Apply the H equal PV. Apply for second figure H equal PV formula. So H is H, they said P equal P2, velocity import 2V. So I can say 2 here, V here, right? That's all the applied mathematics part. So now complete this solving method. Find the first part answer. They ask to show that R equal to 3 mg over n. So show you a good solving knowledge. Sin theta is known, right? So first we remove this P1, connect this to substitute the P1 here. Substitute the P1 here in terms of we get an equation. So I write here 1, 2. Connect the 1, 2. So we can write the P1 that H equal, what is P1? mg sine theta plus capital R into V. Is it okay? Connect the 1 and 2. Substitute the P1 here. Subject P1. Substitute here. Okay. H equal mg sine theta plus R into V. The same, take the other pair, remove the this 3 and 4. Can I say this equation 5? Can I mark equation 5? Okay. Now see this 3 and 4. 3, 4, the same method. But the idea, take subject the P2, apply here. So capital H equal 2V into P2. What is P2? R minus capital mg sine theta. Okay. Can I say that sixth equation is okay? Check, will you? So P2 equal capital H 2V. P2 is what? mg R minus mg sine theta. Now they ask the answer in R 3 mg and n. There no V, no H. So think idea, you equate these two or divide 1 by 1. Fifth equation, divide by sixth equation. Think an easy method. 5 divide by 6. So H over H is 1. 1 equal capital mg sine theta plus R over, yeah, V cancel, 2 into capital R minus capital mg sine theta. Okay, as a cross multiple, 2 times R minus mg sine theta. Here what? mg sine theta plus R. Okay. The problem is find the R. Take subject here. This is 2R minus R. That's equal to 3 mg. What is sine theta? 1 over n. Okay. So you know the R answer. So hereafter they said this vehicle has a maximum speed of u meters per second on a level ground. Show that the acceleration of the vehicle is that when it's moving the inclined plane upward. So another two different diagram, one for horizontal. So I completely come for horizontal part. I draw here horizontal case. So they said maximum speed along the horizontal is u meters per second, right? U meters per second, therefore acceleration is 0. I say in this case the tractive force that's pulling, tractive force is P3. Okay, P3. Here this resistance, once again the same capital R, you know that answer. Now we take something what happened using this formula, this diagram. We take a result and let go to the other part, right? So here I apply the F equal MA, apply F equal MA for this diagram. Our third one, figure 1, figure 2, actually it's figure 3, right? Figure 3, okay? So what the force that side, if I apply P3 minus R equal to 0, therefore in this case P3 equal to R. Can I write sixth one? Equation number 6. Equation number 6, right? Next apply the number 6, number 7. I have 5 and 6, number 7. Next apply H equal PV formula. Next apply, I show here, apply H equal PV formula. So the still the power, what's the power is capital H. P, I said P3. Here velocity is U. Can I say the 8th equation? So by connecting these two, you can find the capital H answer. You can find the watts in a different manner. So connect the 7 and 8. More equation, more work, and easily you can get the full mark. Simple. Now can I substitute for P3 here? H equal RU, also apply the R answer, 3 mg over n u. Can I say 3u? 3u mg over n is the power of this vehicle, right? Now they said show that the acceleration of the vehicle is 2g over n when it's moving at speed of u by 2 along the up. Therefore, last occasion not a maximum speed. That's why there's an acceleration. So we could draw a different diagram. Last diagram. It is actually the fourth diagram here. This is the type question in the structured paper, work, power, energy problem. So, you know theta here, the vehicle moving up, I say the tractive force is P, and its velocity they say U by 2. It has acceleration this occasion, I say F. We should apply, it must be applied, the small f is the acceleration, right? And you know this capital mg weight. Again you have the resistance oppose the motion, they say capital R. So apply everything, find the small f answer. So if you apply F equal ma, apply the F equal ma for that. Actually the fourth diagram, right? So apply F equal ma, upward. So what the force P and minus mg sine theta minus r, okay, equal capital M into acceleration F. You know the R answer, you know the sine theta answer, okay, but you don't know what is P. Therefore we should write the other equation also. Can I write next number 8? Next apply H equal PV formula. Apply this formula. Power is H, tractive force is P, velocity U by 2, okay. That's all applied maths. Now solve pure maths ideas completed. Can I take the 8 and 9? 8 comma 9 gives you what? 8 comma 9, 8 and 9. So here remove the p. Can I say p for what? 2h over u, is it? For p, otherwise apply the p here or substitute the p there. So I can write for this, p is what? 2h over u. Take the p and put it, right? Minus capital Mg sine theta minus capital R equal mass into acceleration. Now we apply all our terms. You know the H answer, you know the R answer. I applied everything, the substitute. The answer is provided, will show that is 2g over n, right? So therefore 2 over u, I can see straightly what is h over u. See, h over u, take the u down, 3 mg over n, right? So there's a 2. What is h over u? See here, capital H over u is 3 capital Mg over n. Okay, check properly. Okay, h over u is 3 capital Mg over n, there's a 2 here, minus capital Mg sine theta 1 over n, minus r. What is r? 3 mg over n equal to what? M into F, equal to mass into acceleration. Now see everywhere m cancel. So here 6 minus 4, 6 minus 4, that is 2g over n. Check the answer, well balanced problem. Therefore acceleration of the vehicle is 2g over n. Okay, see next question number 8. Another study is the friction idea. So I hope you complete this all 10 question or part of the 10 problem you will work. Once you work on, it's very interesting, very clear when I show this full solution. So next I will publish a pure mathematics structure. Hope you will work successfully that all. So draw the question, draw the figure, mark all the forces and continue the problem. The statics force diagram important. The diagram is the main part, the static question. If you misuse the diagram, then it cannot be an equilibrium position. So here what? A semicircular lamina of radius r and weight w is placed on a rough horizontal floor while making the diameter AB vertical. Diameter AB is vertical and the edge A is touching the floor. The lamina is in equilibrium by applying a horizontal force at B. So very simple idea. So draw diagram and mark like this. Okay, this is B. This is A. This kept in a horizontal flow. Okay, that's the meaning here. The lamina. So if I mark this is center, the radius mention R. Okay, this is R. Here R. So you know if it's keep it can be slip according to the rough plan. The friction is given. So oppose the friction force, they keeping additional force to maintain an equilibrium position. So can I say that force is P? Therefore here what the friction force F here, right? So what the another force, weight of the lamina, semicircle lamina. Therefore, that is you need final time papers, final typing paper. You already complete the center of gravity lesson. But the center of gravity of a lamina makes 2 theta at the center, radius A, but that 2/3 A sine theta over theta. I hope you know that. Otherwise, study note at that. Along this symmetric axis, the x bar we call what? X bar equal, I show here, x bar. Theory part of this center of gravity is theta, here theta, then the gravity by G, here O. OG answer is 2/3 what? A sine theta over theta is the answer for a CG, center of gravity of a lamina portion. Center of gravity, radius is A, which subtends 2 theta at the center, right? So from that we can deduce to a semicircle. So here 2 theta, here what happened? Theta pi by 2. If we apply for theta pi by 2, it becomes a semicircle, half circle. So what happened there for theta pi by 2 or 90 degrees? OG equal 2/3 A sine pi by 2 over pi. It's very important part. Before this is important. If you know clearly, apply that answer. So sine 90 is 1. Is it what? 4A over 3 pi. Is the CG of the semicircular lamina 4A over 3 pi. Okay, and a complete. It's at where on the symmetric axis from this diameter, right? This is G, here W. This is the 4A over 3 pi. Okay, that's all the completed diagram. Come to the answer. Mu is the coefficient of the restitution for this equilibrium position, but the simple fraction problem is what? F/r less than or equal mu. F/r friction force divided by the that we call the reaction exerted by the, you also have force R is touching their force. So F/r less than or equal mu. So try to find the F answer, try to find the R answer, go through that value method. But you know what? Don't know what is P. You have to find the P value also. F divided by R less than or equal mu. Okay, therefore for equilibrium of this lamina, I resolve horizontally. I resolve the force horizontally. P equal to what? F. P equal to F. Okay, P equal to F if I resolve horizontally. Okay, what happens if I resolve vertically up? R equal to W. That is no problem. R is known value now, but you don't know what is P. You don't know what is F, right? Both are unknowns that I mentioned. Now we take a moment about what? Take about G. Shall we take about the G, the moments, P into, or take about the O, then no R. That's right. For lamina, take moments about O. For lamina, for equilibrium of the lamina, take moments about O. Take moments about O. Okay, so write this. F into R, small r. In this case, this radius R, right? F into R plus P into R. This opposite direction, minus W, or say other side, W into, what is that? 4R over 3 pi. 4R over 3 pi, okay? Take moments about this point to P F into distance plus P into distance minus W into distance, okay? And you see all R cancel. R plus P equal 4W over 3 pi, say your third equation. That's all applied mathematics. How your pure maths work. Try to find the F value. F is enough, you know the R value. Try to find the F value. A well balanced question for a structure paper under friction. So can I take 1, 2 connected or put 2, 3? Put R for W plus P equal 4W over 3 pi. So here you can find what P answer. P equal to 4W over 3 pi minus W, or take that W and simplify it. Take about minus F plus 4A over 3 pi F equal to R, P equal to R. Okay, that let me write for R here. R is for R. P equal F. Yeah, this is actually F. 4W P equal to F, right? 3 pi minus W. This is the F answer. You know the R answer. Then divide and go to the answer. Therefore, we can write for equilibrium F4R less than or equal mu, right? F4R less than or equal to mu. So what is F answer? 4W over 3 pi minus W over R also W. Is it okay? Less than or equal mu. So W answer available. Answer will find the mu value. Mu is, okay, check W will cancel 4 over 3 pi. No pi in the solid. There are 2 over 3 pi available.